Okay, let's look at an example from the 2.7 homework. And we're actually only going to do one example in this examples video because there's only 5 problems on the homework and all of them are asking the same exact thing. They all have the same format. And so it's all just about looking at different types of demand equations. I figured this one was probably the trickiest, so that's why we're going to work through this one. So here's my demand equation, 400 over p plus 6 raised to the 5th. So instead of x, I'm just working with p, but that makes sense because that independent variable should be your price. So let's find my elasticity of demand equation. Okay, remember that this equation is negative and then x, but in our case it's p times the derivative of the demand equation over the demand equation, meaning we need to find the derivative of this function. So what'll help is if I rewrite this as 400 times p plus 6 raised to the negative 5th. I'm okay with that, right? Since it's in the denominator, I can just switch it to a negative exponent. And now I can take the derivative. What do I do with that 400? It's just a constant multiple, so it's going to stay. And then I have an inside function being raised to a power function. So using the chain rule, I'll just take the derivative of the outside function. So I get 400 times negative 5. Keep that inside function the same. Subtract 1 from the exponent, so I get negative 6. And then, now that I'm done with that outside function, taking the derivative of the outside function, I can multiply by the derivative of the inside function, which is just derivative of p plus 6 is just 1. So as I simplify that a little bit, I get negative 2,000 over p plus 6 raised to the 6th. And there's my derivative. So now that I know my derivative, I can put this all together in my elasticity equation by saying negative p times my derivative, which is negative 2,000 over p plus 6 raised to the 6th power, over my original demand equation, which was 400 over p plus 6 raised to the 5th power. Now I want to point something out. You'll notice that my elasticity equation includes a negative because what happened when I found the derivative? My derivative was negative because the demand equation should always have that negative relationship. It should always be a decreasing function. So these negatives are just going to cancel out. And I'm left with 2,000p over p plus 6 raised to the 6th over 400 over p plus 6 raised to the 5th. Okay, so I have a fraction divided by another fraction. How do I go about evaluating that? I can just flip and multiply. I get 2,000p divided by p plus 6 to the raised to the 6th power times p plus 6 raised to the 5th power divided by 400. I can simplify this quite a bit. 2,000 divided by 400 is just 5, so I get 5p times, and then p plus 6 raised to the 5th divided by p plus 6 raised to the 5th, or 6th. 5 of these get canceled out, and I'm just left with 1 in the denominator. It got complicated there for a little bit, but notice how simple this ends up being. Once I'm done, I just end up with 5p over p plus 6. And there's my elasticity equation. So that's part A. Part B is just asking, okay, what's the elasticity at p equals 6? So that is me specifying a price value. I'm going to set the price at 6 and see what happens. So that just gives me 5 times 6 over 6 plus 6, right? I'm just plugging 6 in for p, and I get 30 over 12, or just 2.5. So that's my elasticity value. Notice that's greater than 1, meaning is this elastic, inelastic, or unit elasticity? Since it's greater than 1, this is elastic. And what did we learn about in our concept video? That means I should lower the price. I've set the price too high for whatever product this is. Okay, well, part C is asking what value of P will maximize my total revenue? Well, if I want to find this value, that means I want to find the specific P value where I don't need to lower the price or raise the price, where that elasticity is telling me to just keep the price where it's at. Well, that sounds like unit elasticity, which is when the elasticity is equal to 1. Remember, that tells me not to raise or lower the price. I've reached the perfect price value. So I can actually solve for that I can take my elasticity equation, which was what, 5p over p plus 6, and I can set that equal to 1 in order to solve for, okay, what price will give me unit elasticity? Then I can solve. Okay, well, the first thing I'll do is I'll multiply both sides by p plus 6. Then I get 5p equals p plus 6. I'll subtract both sides by p, and I get 4p is equal to 6. Divide by 4, and I get p is equal to 1.5. So, in order to maximize revenue, you should sell it for $1.50. And that's all there is to it. It's those 3 steps. First, finding my elasticity equation for my specific demand equation. Next, plugging in a value and determining whether it's elastic or inelastic. And then solving for where I have unit elasticity. Okay, good luck with the other questions. And if you run into any problems, or if you have any of your own questions, please let me know. Good luck, guys.